So I'm Ben, I run product at Coder. I started at Coder because I loved software development and kind of stumbled into the enterprise software development ecosystem. So I'm here to talk about the enterprise developer environment and a lot of challenges that we're running into around that and what we're doing about it. So just with a show of hands, I'm curious, who here understands at their organization how applications are deployed? So this would be the pipeline, the approvals, the server architecture. So put a hand up if you understand kind of the deployment process inside your organization. Cool. So this is basically often represented as the DevOps lifecycle. It's fairly simple, and there's a number of different ways to do this. So to get a little bit more specific now, who here understands how applications are actually developed? So this would be the tools that developers are using to write their code every single day, the languages they're using, the pull request workflow, everything that developers essentially wake up and do every day. So show of hands, who knows how applications are developed? And that's essentially this section of the DevOps lifecycle. So it's a little hard to see on the screen here, but it's the coding session. And this is a very oversimplified workflow, but this is what we see at a lot of organizations. A developer's coding on their workstation. It's typically either a PC in the office, it's a remote laptop that someone is connecting into a corporate network, or it's a virtual desktop. They're coding, they're working on their work, and then they check into a Git repository. There's a CI/CD pipeline, and then it gets deployed somewhere into a cloud environment. This isn't rocket science. This is something that you've all probably seen, typically blown up. There's a lot of other stages and steps. This is just a simplification, but this is essentially what it looks like to develop an application. And you'll notice here that there's a boundary, and the boundary is your cloud provider. Inside this boundary, you're able to apply a bunch of best practices to your pipeline, such as security scanning, infrastructure as code, governance policies, as well as a test suite to ensure that what you're deploying actually is ready for production. All of this stuff happens inside the cloud boundary, and the developer workstation has to be secured and managed entirely separately. IT teams have to do endpoint management, you have to do virtual desktop. It's a different set of procedures that you're doing to actually write the code that's separate from the cloud provider. And in reality, this is quite fragmented inside the average enterprise organization. For starters, there's very scattered, complex environments. It's in a lot of cases, it's a wild west. There's different developer groups who have Windows machines, Intel machines, Mac machine, or Mac Intel, Mac M1, M2, M3. There are contractors connecting with virtual desktops. There's bring your own device models. There's also a lot of developers will provision a VM and connect to that VM every single day on your organization's AWS account and use that for their coding because their local machine is so locked down. Aside from the laptops itself, there's also different tools that you have to support for the developer. So some developers prefer IntelliJ if you're doing Java development. VS Code is the largest and most dominant editor right now. And there's also legacy editors such as Eclipse and Visual Studio for .NET development and working on desktop applications that you may be deploying some pieces to the cloud floor. You also have to connect to cloud services in your local workflow. So developers are working against databases, they're working against secrets, they're connecting to pipelines, all of these things that you essentially have to support. And then there's developer tooling as well. There's GitHub Copilot, there's Amazon Q, there's Python, Java, the actual tools that developers are interacting with every day. And if you're a platform engineer or an IT manager, being able to support this matrix of configurations becomes extremely difficult. There's basically no way to create a golden path if you have to support all these different tools, editors, connections into cloud workspaces, and actual IDE extensions as well. So that's what we see in a lot of organizations we work with, is that it's a wild west. The other side of that is that some organizations have actually standardized their developer environment, but it sucks. It's virtual desktop. The developer's not able to run any modern cloud-native workloads onto their standardized virtual desktop. It's slow. Developers are connecting from various regions. There's low latency. And any time a developer needs to install a tool, whether it's Copilot, Docker, Amazon Q, any type of tool the developer needs is a ticket to the IT team, which takes time and is completely separated and fragmented from the rest of your cloud-native workflow. So that's where a cloud developer environment comes in. And you'll notice that the workstation is still there. Someone needs something to connect with, but the actual coding occurs on a cloud developer environment that uses the same tooling and governance across your cloud developer, or across your software development lifecycle. That means that your security scanning, policies, dev tools, container registries, everything that you're doing for staging, testing, production can be applied to the developer environment as well. And you no longer have to battle with IT teams to install specific tooling in your workspace because you already have a cloud native pattern for installing this tooling in a Docker application or when you're deploying out to EKS. A lot of this has already been automated and created for the cloud. And this is what Coder does. So this is Coder's logo. There's a lot of other cloud developer environments out there, but this is essentially the model that I'm here to talk about today. So a little bit more about cloud developer environments. It's consistent, secure tooling. So a container or a VM image is used to essentially standardize the tools the developers use. We typically see a platform team or a developer experience team managing cloud developer environments, and they're the ones who create the VM images for developers, and then developers can then apply customizations on top with a spec. Now, the idea of developing on a remote server is not new at all. It's actually how development started with people time-sharing mainframes. But where kind of cloud developer environment comes in is it's very fast networking, and you're able to access cloud resources as well. And for the developer, the coding feels local. So developers are able to use their desktop editors and use those as essentially a thin client connecting into a remote backend. There are also web-based editors that you can use if you want to code on an iPad or a Chromebook. But we find that software engineers really like to use their local desktop editors, but kind of enhance that with the power of a cloud environment. Now, this is the reference architecture for a cloud developer environment. It's quite simple. It's an ephemeral container and a persistent disk. The ephemeral container is essentially the tooling that a developer will use. It has Python, Java, Docker, whatever the developer needs is in that container image. And then the disk is what stores the developer's personalization and source code and whatnot. Now, a cloud developer environment will integrate with your Git provider so that you're able to kick it off into a pipeline. It'll integrate with your container registry, but this is essentially the architecture of a cloud developer environment. It's quite simple, and we actually think at Coder it's simple to a fault. The typical model for a cloud developer environment really only supports 20% of software engineers in the G2K org. Now, you'd think every developer would be able to move over to containers pretty quickly, but that's just simply not the case. There are developers who are working on mono repos. There are people who work on desktop applications. There are on-prem instances that developers need to integrate with as well. So a cloud developer environment by no means is a full solution, which is why we have the term the enterprise developer environment. Now, the cloud developer environment is part of it. There's still the nice cloud native model with a container and a disk, but we believe the enterprise developer environment integrates with a lot more. There are secrets management. So if you're a developer, you need to be able to get into your secrets and access the kind of cloud APIs, whether it's an OpenAI API key or something to communicate with an internal app gateway. All this stuff needs to be provisioned alongside the container and the disk for the developer, and deprovisioned when the developer leaves as well. So we at Coder are lifecycle managing all of these resources. VMs is another one. We actually find that a lot of our users who work on monorepos prefer to provision VMs as opposed to containers for the developer environment. VMs are nice and isolated, they're easy to tear up and tear down, and with cost-saving features such as shutting down the VM every day and patching updates every night, VMs are actually quite a good approach for cloud developer environments. Another thing we hear is access to remote data sets. So if you're an ML developer, you don't want to have to be able to do this training on your local machine. And as a kind of security operations team, you don't want data to be able to go from the developers, from the cloud into developers' workspace. So we're seeing a lot of people deploy access to data sets as well. Windows is another one. A lot of people are still need access to Windows environments, whether it's for QA, and we're seeing this quite a lot. People deploy Coder on-prem and in AI assistants. And then the final thing to mention here on the bottom is that in 2025, it's a lot more than just software engineers writing code. And the typical software development lifecycle is great, but there are a lot of other life cycles for data scientists, external contractors, ML engineers, if you're an analyst or a quant or DevOps as well. And we believe the enterprise developer environment not only solves the typical software development lifecycle, but can fit into an ML ops workflow as well. So I've been at Coder 4 years, and over the last 4 years, I've had the privilege of working with two separate kind of profiles of customers. And for simplicity's sake, there's the cloud native tech hubs. So these are people like Netflix who have been doing something like cloud development environments for a while, but don't want to reinvent the wheel anymore, so move over to a platform like Coder. And these people will typically work in a monorepo, and they're giving each developer a VM. And on the other side is kind of the regulated enterprises. And these are people who really care about data sovereignty. They're running developer environments air-gapped or in a zero-trust cloud environment, and both of them really benefit from the flexibility of a cloud developer environment. You'd think that they're polar opposites, but in reality, a lot of the requirements that these organizations have are very, very similar. Now, over the last 4 years, we've found ways to kind of create opinions on what it looks like to introduce these to your organization. Introducing any type of change, let alone asking developers to change their workflows, is extremely difficult. So we've done a lot of things the wrong way, and now we're starting to learn what works at Coder. And the first is actually quite simple, and it was that original reference architecture we had with a cloud developer environment with a container and a disk. Essentially, as a platform engineer, you can create a universal image, similar to the desktop images that you may have today if you're managing desktops, which is a one-size-fits-most approach. And this is a great way to kind of show the magic of a cloud developer environment without having to require every single developer migrates their code base and their workflow. So I'll be talking about that a little bit more. Second, allows teams to bring their own dependencies into a platform like Coder, and Coder can lifecycle manage those. Dev containers is a spec that does this particularly well for people doing local development or working on other CDE platforms. Third is we see a lot of cases where organizations want to bring on additional clusters into their workloads. So if each team has their own cluster or their own VM pool, we're able to support those in our platform at Coder as well. And then finally, we believe the enterprise developer environment should support all types of software development, and that includes things that you don't typically think of as a containerized workflow. So that would be Windows development, Android development. We compile Coder for Mac OS as well, so we really hope to be able to support Mac OS and iOS development as part of the enterprise developer environment. So starting simple, universal images. Now, the goal of a universal image is essentially to have a quick win and a really great demo for a cloud developer environment. So if your boss was to log into the platform, provision an instance, and write up a Python script, for example, it would just work. So you'd have a lot of tooling that developers are typically used to inside their environments: Python, Java, Docker, Go. And the best way to do this is by running a survey of your developer population, figuring out what tools they use, and particularly the tools that are most painful to use locally, make great carrots for moving into a cloud developer environment like Coder. Microsoft makes dev container images. They're a great place to start. They have an image for each popular language, and then you can take them, add them to your registry, and modify them to have the kind of patterns that you're used to in your organization. Next is bring your own dependencies. The dev container specification is the most dominant spec that we've seen at this point, and this allows developers to specify in their Git repository which projects they want and what languages and tools they need inside their workspace. So in a Git repository, a developer would say, we need Python 3, Java 4, and by creating that dev container JSON and bringing it into a platform like Coder, Coder's then able to build and create those declarative developer environments for specific use cases and for specific tech stacks. An optional component here too is if your organization has artifact management and vulnerability scanning, you can apply that layer into the dev container spec. So it is allowing developers to self-service the tools they want, but it can be coming from your artifact management location, so that you don't have to worry about a bad version making it in. The third pattern that we're seeing people do, and this is the advanced Coder users. So these are people who have Coder or a cloud developer environment deployed out to over 2,000 users. They want to be able to bring in different clusters and different platform teams outside of the kind of core developer use case. So a typical example here is a data science organization has their own cluster, they have their own namespace, and they want to start provisioning environments that match the rest of their pipeline. So you can install a Coder provisioner inside one of these clusters and give developers a one-click environment inside a second cluster from what you're originally managing with Coder. And we see a lot of people doing this to ensure consistency across other environments they may have, whether it's staging, test, prod, QA, by provisioning dev workloads in the same location. Finally is edge cases. There are a lot of edge cases with doing remote development today. This would be Windows development, iOS development, running CI and staging with Coder, and The cool thing here is we had a lot of our users doing this stuff with Coder before we even thought of it. We had people scripting around Coder to do Windows. We had people scripting around Coder to do embedded development, where they're actually coding on a local machine, but then reaching out to a Coder workspace to do that build in a consistent fashion, and then syncing it back into the workspace. So there are a lot of models here where you can do AI, or you can do kind of remote augmented development, or AI augmented development with Coder. But today it requires a lot of scripting, port forwarding, local sync, and over time at Coder, we're going to be building in to support more of these use cases and make it more of a first-class citizen inside of the platform. So that's the enterprise developer environment. It solves for more than just the software engineer. We're thinking about other personas, ML ops, data scientists, external contractors. It's a way to roll out modern and secure tooling as part of your cloud-native best practices, and it's used for a developer environment standardization. Now, if you're looking for more information, we have 3 case studies that we've worked with several customers on that you can look up. It's on our website. And if you're looking for someone who's not using Coder, both Slack and Uber have very good blog posts about how they do remote development. And the cool thing here is each organization has a slightly different pattern for how they're doing it, but it's all to solve the same goals, which are the 3 bullet points I put above.